Now that we got a feel for how we describe and how we can talk about software process, let's talk about how we arrange those activities, those methods, those artifacts into creating a software project. Now, there's many processes out there, and you are going to be discovering more about many of these as you go through the first discussion board. Your task is going to be to investigate them and describe them in much more detail. One of the things you need to do is recognize what is a software process. It needs to be talking about activities, methods, artifacts. If you aren't talking about the specific task you're doing and how you're doing them, and then dealing with the full software lifecycle, you're not really dealing with the full process model. So when you see the word object-oriented or you see the word structured design, those are methods within a process. And so what we want to do is identify the characteristics that you're going to be looking for, that we're going to be talking about at this first discussion board. So when we describe the process model, we want to talk about how I get from start to finish. Not within one activity, that's just a method. But how do I start from nothing and end up with a product and maintain that product, even beyond that, that step of actually releasing it out to the public. And so I want to talk about how do I flow between those as well as far as when I'm defining the process. Not just how do I do one activity, how do I get from planning a project to requirements, to design, to implementation, to testing, to release, to warranty period. That's a lot of politics, it's a lot of business, it's a lot of finances, it's a lot of technical needs that get thrown into the mix. And that's partially what process is there to solve. So the most common way of solving this problem is using a linear flow model, sometimes also called a waterfall model. In which case, our activities start at a beginning point and progress on to the end point. You can think of it like watching a movie. You don't jump around inside of a movie. You start at the beginning and you go to the end, and the story tells itself. Now, this has some really clean advantages. From a scope standpoint, I can understand exactly everything that's involved with each phase before I move to the next phase. I can keep everybody clearly understanding what's going on in my project, and I have a clear idea of where I'm at. If my requirements aren't finished, then I'm not out of the requirements phase. If I'm not done doing the design, I'm not all the way there. So the idea within this is I'm going to start up at the system level and define everything I need from my system. And then I'm going to break that down into my software requirements. So there's some things going to be done in hardware, there's some things that people are going to do, and then I define my software requirements. And then I design the code for that. So again, I don't start my design until all my requirements are finished. And then when my design is finished, then I can start building it. I'm not going to waste time building things that might change later on because I've designed out everything I need. When I finish building it all, I test it, and then I can release it. And so this standard approach is nice and easy to define and nice and easy to plan. It's been used for a long time, so it's really easy to describe, understand, pick up. And it's easy to track the progress, as we said. We know where we are based off of what major phase we're in. The bad part about this is it's unrealistic. I don't always know all the requirements up front. I don't always build the design that's perfect, that never ever changes. I basically don't get a working version of anything in my project till the very end using this approach. And sometimes it's nice to be able to get a look at, well, what's these screens going to look like? What's the user interaction going to look like? So we often have a lot of lost resources. As a developer or a tester, you might be waiting around for somebody else to solve some problems. Hey, I've been put on the project, but the requirements aren't checked off yet. I can't start. Hey, I've been put on the project, but I can't test anything because the code's not released. Where this basically becomes an unrealistic way, an inefficient way to manage resources. So sometimes we talk about what's called the prototype model, where what I do instead is I cycle through talking to the customer, building something, handing that to the customer, and going through small iterations. This is done with an agile or extreme programming model. The idea is to have the customer closely tied into there, and I can build small little products that don't take very much time and that I can throw away as it goes. So beyond that, we can talk about the requirements as a way of capturing exactly what I need in not having to do it in some sort of formal high-level way, but some sort of interactive way. And I can verify that the technology is going to work and the solution is going to meet the customer needs right up front. The problem here is customers aren't always savvy. If they don't understand the nature of prototyping, that, hey, the first thing you're going to see isn't the final product, they might say, hey, well, you built this, let's go, release it, I'm good to go. It's like, no, this is just some screens. I don't have the whole back end that's going to allow all this to work at this point. And the other thing about this is that it doesn't have the same rigor that's involved. Sometimes you just build stuff and run with it. And sometimes it's really hard to come back and change when you're in flow. So you build something, but hey, it works good enough, even though you built something knowing it was going to be a less than great way to do it, but then you have to live with it because nobody's going to allow you to go back and fix it. So think of it this way. I don't want to fly in an airplane that's just kind of been thrown together a little bit at a time. I want to have some sort of system view of the airplane. Prototyping is, an airplane is not about just the customer needs. Hey, how does this look? It's also about safety and integrity and the right weight ratio and making sure the batteries don't catch on fire in the new electric plane. And it's not saying that Boeing did that when they built the plane. It's just saying that even with the full systems approach, you can have problems. So imagine how much more difficult it is when you build things up like this. So not every project is built for this rapid prototyping phase. So the combination between those two is what's called the incremental model. The idea here is I'm going to build the big product, but I'm going to build it in chunks. I'm going to build some part of the system, and that part of the system is going to be something that's production ready, but it's not going to be the full of everything. I might not release that production-ready piece. I may just build the login feature. Why would I build a site you can log into and have nothing to do? But when I build that login feature, it's going to be great. It's going to show how somebody logs in, but it's also going to be secure and safe and make that happen. It's not to say you can't prototype and do incremental models. You can prototype within that. But the idea here is I have phases. I build all of my requirements for a phase, then I do the design, then I do the code, then I do a test. And that's going to be an iteration of some core piece of the system. And then when I go to the next iteration, it's going to do everything again. Requirements, design, code, test. But it doesn't start necessarily in a waterfall way. I don't wait till one's tested and released to start the next one. I might do all the requirements for phase one. And if my job is an analyst, I might then immediately start the requirements for phase two. As the coder, I might do all of my design for phase one, start working on the implementation for phase two, and those requirements, they're waiting for me. And so the second I toss it over to testers, I can start working on phase two. Oh, we got a bug, I go back and work on phase one. Oh, I'm done with that, I'll go back to work on phase two. So basically, you're using your assets well. The idea is to iterate through, and like the prototype, I am getting quicker results than a waterfall, but I'm still using the full rigor of a process. And so, as we said, that allows us to build the core very quickly and put that out there so people can see it. That lets me take on difficult technical challenges, lets me let the customer see what's going on. And then it compresses the schedule in that I can release without having everything finished. I can have parts of it finished. So you can think of it this way. I don't want to release an airplane without seatbelts on it. That's not going to happen. Some projects, again, can't let that happen. But I can take a video game, perhaps, and release it with just the 5 maps that are ready and add another 4 or 5 maps later on that people are going to play on. I can release an accounting application that does all of your federal taxes, but maybe isn't ready to do the state taxes yet. So that might come a couple weeks later. That'd be okay. At least somebody can get started putting your data inside of that. So it's really great also to keep the full staff occupied. Now, the problem with that is it complicates planning. I have to understand what's being done in each release. I have to accommodate in my design for things that I don't know fully defined yet. I have to be ready and predict what things might change and maybe design ahead, or I have to do some rework on things in order to get it done. But that's the trade-off. I have certain efficiencies which I'm getting in use of people, and then going to have to add a little bit of rework occasionally. I'm going to have a quicker understanding of the whole system, that's the system in part, but I might have to have a little bit longer time actually before I get the system as a whole. So that is the high level look at how we can define processes. It's a start to what we can define out there. It's a high level view. Your job is going to be to go into this detailed processes, whether it's going to be joint application design or rapid application design, or you can talk about the rational unified process, or DO178B, or whatever you want to look at, and give us some details. Teach us a little bit about this. And so basically, the collection of all of our little stories can tell us a little bit more about the different ways corporations you might work for can approach software design processes.